In this lesson, we're going to look at when a circle and a line intersect. Now, there's actually three scenarios. There's a chance that they may never intersect, or they might intersect at 1 point or possibly 2 points. There's two ways that we're going to look at doing this, and one is solved by graphing. We're going to graph the circle and graph the line, and then decide if they intersect or not. Keep in mind that graphing is not as exact as when we do this algebraically. In this example, we need to graph the circle. It's ready to go in the correct format. But that equation of the line, we need to solve for y and make sure your y is positive. So subtract 2x and then divide by negative. Now we're ready to plot this. So plot point at -5 and then go up to right 1. Our circle is centered at 0, 0 and has a radius of 2. Now, depending on how you sketch this graph, or if you graphed it on graph paper, there's a chance that your circle and line may look like they intersect. But in fact, they do not. It comes really close, but they don't touch. In this one, we need to get the linear solve for y by subtracting x. We would plot a point at 3 and fall down 1, right 1 to get our slope. This circle is centered at 0, 0 and has a radius of 3. We see here that they intersect at 2 points. The other way is to solve algebraically. Make sure you have these copied down in your notes. Sounds a little bit confusing, but with a couple of examples, I think you'll get the hang of it. Make sure that you take down all of the notes as you work these two problems. Copy this down. Look at that linear. I've solved mine for x. I've moved the negative y over by adding y. I'm going to take y plus 2 and substitute it into the circle where there used to be the x. I need to multiply y plus 2 times y plus 2, combine my like terms, and now try to solve this. I'm using factoring to solve mine. I've got two solutions for this. I get y is -5 and y is 3. So on this particular problem, we need to substitute two different values in at two different times. So I'm going to section this off. We need to plug in -5 and see what we get. And now we need to substitute in 3 and see what we get. Now, this means that the circle and the line intersected at two ordered pairs. So what are the two ordered pairs for this? One more. We have a circle and a line. It looks like it's going to be easiest to solve for x on this linear. Subtract the 3y. Now take -3y plus 10 and substitute it where the x is in the circle equation. You're going to have to distribute -3y plus 10 times -3y plus 10. Multiply all of that out, and this is what you would get. Combine your like terms and bring the 10 over. I'm going to use factoring again to see if that would work, and indeed it does. Now there's good news on this one. When we solve for y, we get y equals 3. Now you get y equals 3 on both parentheses. This is called a double root. Technically there's only one answer. So this is telling us that this circle and line intersect at 1 point. Now all that's left to do is to plug it in and solve for x. Don't forget to write your answer as an ordered pair.